Hi, I'm Steve Cox. I have my own company called AMFORi Consulting. My background is I worked as a professional mechanical engineer in the automotive industry for more than 30 years. But for the last 8 years, I've been involved with 3D printing and additive manufacturing. I spend time developing applications, showcasing methods of 3D printing, and helping clients adopt this technology. And one of the things I enjoy the most is exploring what this technology can do and how people can use it. Ultimaker and the Ultimaker 2 that I bought 8 years ago really started me out on what I've heard called a walk in the woods with additive manufacturing and 3D printing. It still ranks as one of the best decisions I've ever made because it works straight out of the box and it allowed me to concentrate completely on applications rather than just making the technology work. In whatever I do, I'm always striving to achieve the best possible quality output, and I'm sure many of you are the same. But those attributes of quality always stood me in good stead. So how do you create the best possible quality with the highest level of efficiency and the minimal amount of waste? It's something that I'm always keen to explore in the work that I do with 3D printing because I'm always wanting to present the best possible way of 3D printing to the clients that I work with. So that lean manufacturing mindset completely frames what I do now. I spend a lot of time when I'm designing and setting up 3D prints, and that often means spending time in the preview side of the slicing software to ensure that I know what kind of output I'm going to get and it's going to achieve the quality that I'm looking for. Thin walls and small features can often be challenging when striving for that kind of quality and efficiency in 3D printing. And sometimes the requirements of 3D printing can bear too heavily on the design. What do I mean by that? Well, maybe you're prototyping using 3D printing for a different method of manufacture. And the design requirements should be driven by the ultimate method that you're going to use to produce that part, not by the 3D printing side of things. Take as an example this design, which I've created using Autodesk's Fusion 360 and the new plastic design tools that they've just introduced into that software to make designing of injection molded parts more efficient. And those injection molded parts are the kind of thing that often use thin walls, clipping features and webs. In this example, the parts were designed around the rules for a 1.5mm injection molded plastic housing. That 1.5mm wall thickness for these parts presents some issues when it comes to 3D printing. 1.5mm isn't an exact multiple of a 0.4mm nozzle, if that's what you're using. It's also not an exact multiple of a 0.6 or a 0.8mm nozzle either. But those inefficiencies are dealt with by Cura 5. In Cura 5, the introduction of variable line thickness deals with those inefficiencies of creating that 1.5mm wall thickness. That's done automatically by the software and no user input is required to create those variable line widths. So let's take a look at that 1.5mm wall thickness. In the preview of the slice in previous versions of Cura, you can see that that 1.5mm wall is created from 2 outer shells, 2 inner walls, and a very thin line of infill. And in the corners of the part, some very small amounts of infill applied. Is that really efficient? Is that really the best quality? Is that really going to give you the best possible 3D print? Now let's compare that with the same part sliced with Cura 5. That same wall thickness now is being created by 2 very even outer shell lines and 2 very even inner wall lines. No thin infill, no messy condition in the corners. That has to be much more efficient because we're talking there now about using 4 toolpaths instead of at least 5 in previous versions of Cura. It's a similar story when we look at these small clip features that are holding the 2 parts of the housings together. Again, let's look at it in previous Cura. You can see that the clip is being created by an outer wall, an inner wall, and again, a small squirt of infill in the middle of the clip. Let's compare that to Cura 5. In Cura 5, you can see those same clip features being produced by using 1 single outer shell line and 1 single inner wall line. Again, those clips are now being created in a much more efficient manner. There's an overlap condition that I've created in this design that you can see in this image between the upper and lower case halves. With this overlap, there's a 0.25mm gap between the 2 overlap conditions to ensure there's no interference when the two case halves are brought together. That means that we end up with a very design-driven dimension of 0.625 millimeters for these overlap wall thicknesses. So let's take a look how previous versions of Cura deal with that 0.625 millimeter wall thickness. You can see here it's doing it by creating two very uneven shell lines. Let's contrast that to Cura 5, where you can see that same wall thickness is being generated using a single shell line. That's one toolpath instead of the two toolpaths required in previous levels of Cura. The upper case half has web features designed into it, which are typical of injection moulded parts of this type to increase the stiffness of an open design such as this. In this case, those web features are 0.75 millimeters wide. And that's a rule that's driven by the injection moulding side of things, where you need a web thickness of half the main wall thickness to ensure that you don't get any visible sink marks on the outer surface of the part. So you can see here that previous levels of Cura create those webs using two uneven shell lines, and also there's some non-uniform infill lines going on that you can see in this preview image. Let's contrast that to Cura 5, where those webs are created using two even shell lines. Again, massively improving the efficiency of the 3D printing and also hopefully the quality. All of these improvements contribute to a better, cleaner, higher quality 3D print. The efficiencies in toolpathing created by variable line width control bring about a significant reduction in 3D printing time. In this example, the print time using Cura 5 for the lower casing was 17% less than when the same part was sliced using Cura 4.13. And for the upper casing, the print time reduction was 15%. That's a really beneficial time improvement, and one that really fits well with my desire to create the most efficient 3D printing experience with the highest possible quality. Oh, remember that 0.625 millimeter wall thickness? How did that turn out? Well, let's take a look. That's pretty impressive. And that's the kind of quality that I'm looking for in the output from my 3D prints. So all of the things that we've seen in this presentation show how Cura 5 contributes to better quality printing with higher efficiency. That for me is a perfect combination. And the great thing about Cura 5 is that it does this for everyone, not just for those people using Ultimaker machines. So you can see here that these parts were produced on an Ultimaker 3 that's 5 years old. Not the latest S5, not the latest S3. And that shows that Cura 5 delivers excellent results no matter what the age of your machine. I hope that's given you a really interesting insight into what you can expect from this very latest, exciting version of Ultimaker Cura. Thanks for listening. Enjoy the rest of this showcase.